Hi class, let's do this. We are going to write a function to insert a node in the linked list, not like the one before that we insert only at the head. We are going to specify where we want it to be inserted. So look at the definition of this function. I have a precondition because this actually doesn't work if the linked list is empty. And so if the linked list, what it means is that after me has to be pointing to that particular node if it has only one node. Otherwise the function wouldn't work. So let's look at the code and we can think about why. After me is passed by value because it's just a pointer that points to the node that I want to insert after, and so that particular pointer is not going to change even though the node that is pointing to by it would be changed. Where are we? Where we are at 8, 9, 10 again, let's say, and we want to be able to say, hey, I want to add 20, a node that has a value 20 after the node that has a 9. So let's see how it works. So to insert a new data with the data 20, or new node with the data 20, we are going to create this pointer, create a new node, set 20, and then next will be set to after me next where it's pointing to. So it's this record, right? And then what we are going to do is then set this after me next, or after me arrow next, for it to point to this. So after me arrow next will equal, and we would then take this out and set it to null pointer. That's usually its best habit to do. So the plan looks more complicated than what I was saying. So create the node, insert at the node pointer, insert, create a new node, set the node's data, set the node's pointer next to equal to after me arrow next, and then set after me arrow next to equal to insert, where because you want this one to point to here, right? And then we set insert to null pointer. So very simple. Let's look at the code. So what we are doing is we have already three nodes inside, and then we will search for the node 9 using the function that we created before, and then we know where the 9 is, so have a pointer to it, and then we insert, passing in P9 as the after me, and then passing the value, I think in our example is 20. So we would then print the node again to see if we insert it correctly. Before we go to run the code, we should look at the code first. So if you look at the two, the head insert and the insert is very similar, except that we replace the head with after me arrow next. You see head replaced by after me arrow next, and everything else looks exactly the same. And then let's consider the situation where head actually is pointing to a null pointer. If we then pass head in here, you will see that it wouldn't work just by thinking about the case that when head is pointing to a null, right? And so you actually need to change the value of head, but this is passed in by value and not reference. Okay, you can say that, okay, what if I pass in by reference then? Then can I change it? But the thing is, you actually don't want to have to handle this special case. All the cases after me should not be changed, but just the head. And also you already have head insert. So why to make this complicated, right? If people want to insert a note at where the head is as the first record, they can just use head insert. And so we won't handle that special case. And that's why in the comments, we write that for insert, after me is pointing to a node in a linked list, and the linked list has at least one node, therefore. So this is repeating just the code, and then we did consider the boundary case. If we really think about it though, because we have to say after me arrow next, and if this is a head and it's pointing to a null pointer, this actually wouldn't work, right? Because there's no next. And if we try to set the head pointer arrow next to something, it will give you an error, and that's why this doesn't work for the case when head is pointing to null pointer. So does it end well? If for example, after me is pointing to 10, right? Then would it work? Then next will we want to insert 20 behind 10, and so next will be set to null pointer. Let's see if that happens in our code. So we have this setup. Okay, we would insert this equals to 20, and then insert next will be okay, and then it will be equal to after me arrow next. So after me will be pointing to this data, and after me arrow next will equals to null pointer, and so it will just set insert arrow next to null pointer, which is fine. And then after me dash next equals to insert. That's exactly what we want, because that will insert that node at the end, right? Let me see if I actually do it correctly. Right, so insert next will equals to null pointer, and then this guy will then point to where insert is pointing to. So we check that it actually ends well. All is good. To recap, we learned about how to write an insert function, and that is different from the head insert function, where you would give the insert function a pointer to a node that you want to insert after, and showing really how important it is to consider the boundary cases. Next, removing nodes. See you in the next video.